Bismillah ar-Rahman ar-Rahim. This is a lecture number 1 on the topic of linear momentum. And this topic is newly added in our AS Mathematics Mechanics paper in 2020. It was not before. Okay. So let's start. And special number angular momentum is not in our syllabus, only only linear momentum in our syllabus. So let's talk a basic definition. All of you know it because you're 11th grade, so you know it very well. The basic definition: momentum is actually equal to product of the mass with velocity. There's nothing hard, I think so. Mass with speed or velocity, no problem. But is it because if you take a velocity, so mostly we take a velocity. But if you're going straight line, speed and velocity same thing, so not a problem. Okay, so that is why mass into. So let's start some ideas here. Okay, so for example, this question, I just take it here and I will give you an example to understand. But before I start, this a very important property we'll use, and that is a very clear. Let's say this is observer's eye. This is observer's eye. If one particle will go away from observer, we done it already in chapter of kinematics. When particle goes away from observer, velocity always taken as a positive. And when any particle is coming back to observer, velocity taken as a negative. This is a key in a whole chapter. So keep in mind whenever the particle is going away, so velocity positive, coming back, velocity negative. Don't forget this property. So this same property I'm going to utilize here even. Inshallah, you will come to know. Let's start one small example. Okay. The particle of mass is 4 kilograms and the initial speed is 5. Okay. And find the momentum. First part, the piece of cake. So simply mass into velocity, 4 into 5, 20. So alhamdulillah, Rabbil Alamin, Newton's, because momentum will deal as a Newton seconds. I think all people understanding the units. Okay. All right, let's move on next. So this is important part which I'm discussing now. The magnitude of, when you say magnitude, so direction is not a matter. Make sure magnitude is called without direction. So without sign, it is called without sign. Okay. So change in momentum is if the velocity of the particle increased to 12, starting from 5, ending at 12. So I given starting velocity u as a 5 meter per second, and last velocity I will deal from here as a 12 meter per second. Okay, so he's saying what find increase or change in the momentum, and it's a very simple formula. Change in momentum, we can get simply change M shortcut I'm writing MV minus MU. Okay, so it is a very clear approach. Okay, and the mass is what here, 4. Final velocity is 12. Initial is 4, is a 5. I think it's a very simple. So I think we can get it 48 minus 20. You got it 28 Newton second. You can see even here. So it's a simple a piece of cake, but it is not applicable, this property here. I think when we move on next page, it will use here. For example, here is an important example we have available. So let's read this question. Okay. The mass is a 5 kilogram, 2.5. Initial velocity is 3. Find the magnitude of change in momentum if final velocity is 5, but direction is unchanged. This I'm not doing the same. But the final velocity is 5, but direction is reverse. So this part I'm going to do now for you. And get ready. So what we'll find it, mass into velocity, common sense, one particle, let's say this is observer's eye. So one particle first is going away, and then he said that it is going away. Second time it's coming back to observer, because he said that is the direction reverse. Okay, so what I can do, a change in momentum formula, you know it very well. I'm writing it here. Change in momentum. So formula is very clear. So mass into velocity, mass into velocity. Okay, mass is very clear, 2.5. Final velocity is what, 5, but it's coming back. I will write -5. Okay, mass is again, I have 2.5. Initial velocity is 3. I believe you're understanding what I'm saying. And this is coming -7.5, and this is becoming, wait a minute. They check again. No, this 12.5. So 2.5 into 5 is a 12.5. This is a 12.5 negative. Negative 12.5, and this is becoming 7.5. And if you check it carefully, you get a what? 19.5 negative. But you know very well, sign has a no matter, so we will eliminate the minus sign. But interesting part here, I can do in this a second way. Suppose observer's eye is not here. Observer's eyes is on the other side. For example, observer's eye is on other side. Then what happens? Then this will be negative and this will be positive. So in this option, what will happen? So you know it very well. I will change reverse the sign here, negative, here positive, and let's see what happens then. So this is negative sign, this negative into negative give you positive, and I get a same positive answer. You see that that answer is not affecting your observer's eyes here or observer's eyes there. Not a big trouble, and answer final answer same because momentum always positive. In the previous example, I got negative answer. I eliminated and I got a 19.5. I hope so. You got the point very clear. Now, give me one favor because let me read this question. You have to try one question. The ball is, yeah, I think this question is good to do. Okay, well, let me read for you. A cricket ball of mass 160 grams is, okay, and hit the reach the ball. And you know, first ball is coming towards bat. Okay, first ball is coming towards bat. And after hitting, what happened? It will go backwards. So direction is matter. So make sure one velocity is positive, one velocity is negative. So all people, I'm going to pause the recording. So you have to try this question number 5, and then I will do this question myself. They can check your answer. So take your time. I'm going to pause the recording. Yes, student, I think you have taken a reasonable time and you finished. And now I'm starting now. A cricket ball mass is a ball is given mass 160 divided by 1,000. Okay, I got a kilograms. So you know it very well. This becomes 0.16 kilogram. Okay. Now, sorry, 1 minute, please. 1 minute, 1 minute, 1 minute. Okay. So this is a zero. Okay, this is clear. Now, after this, what is story here? So he's saying that the baller, the reach the ball, the ball. Actually, talk about ball. Reach the bat with speed of 18. So it means baller reaching the bat. For example, I just do another way. So I just do it in a sense of the observer. Although bat is also there. Okay, I take like do like this. For example, this is a bat. Okay, and you can imagine that ball is coming first of all towards observer. Okay, so first ball is coming towards observer and speed is what? Speed is 18. All right, and after hitting the ball will go back there. Okay, ball will go away from the bat or away from observer with speed of what? He given us speed is 25. Okay, and back to baller is very very clear approach. Okay, find the magnitude. Magnitude means if sign comes negative, eliminate the negative sign. He's saying change in momentum. So let's try to find, and what is a method to find a change in momentum? Change in momentum. So formula is very clear. Mass into final velocity, mass into initial velocity. Mass is 0.16. So final velocity is 25. It goes away, and mass 0.16. Initial velocity negative 18. You were surprised why negative 18? I said before, when it's coming back to observer, velocity is negative. Going away from observer, velocity positive. And that is why I kept negative with 18. And I believe this is nothing hard. And now I'm going to complete my question and 0.16 into 18. And my answer is coming 6.88. If your observer eye is here, then you will get negative answer, but negative you have to eliminate. Newton seconds, I believe you got the point very clear. And this question is over. And now I'm going to give you another task. First, you try this question. Otherwise, I will do that question. Number 6. All people, I'm not erasing the solution. You can copy if you want and make correction. And I'm going to stop recording. All people, all of you, please try question number 6. But please give one favor, sketch diagram. How sketch diagram? The ball is dropped from the height. So first it will drop and then it will bounce back common sense. You keep your eye, observer's eye down, or keep observer's eye up. No problem. Both are correct. Okay. So first is falling down, is bouncing. So please write data, draw a sketch, a rough diagram, and then try question number 6. I'm going to give a pause. I'm going to stop recording. So take your time, please. Yes, student, I have given a reasonable time for this question, and now I'm starting this question. First of all, let's try to read question. He must say mass is of 300 grams. So mass is 300 grams divided by 1,000. I got 0.3 kilograms. So this part is clear. Okay, drop from this is very clear. Dropped onto floor from a height of 2 meters. So it means it dropped from a height of 2 meters. Is a means s is equals to, or height is equal to 2 meters, coming from down, coming from top down. So a drop means, what is drop means? Clear sense, starting velocity 100% zero. Okay, now and rebounds the height of the 1.4 meters. It means it will go up back, and it will travel 1.4 meters upwards. Okay, this is a ground. Change of momentum is after hitting the ball is our target. It means two velocities are very important. This velocity just before hitting, and this velocity just after releasing. Two velocities are our concern, and I'm going to shift this question on the other page. So all of and hold on. When it will go reach here, 100% final velocity is zero, because there are two motions, one coming down and one going up. To make a difference, I deal here one, and this is two. So let's move on this page. So I'm going to do the same question here, full here myself. So inshallah, I believe you understand. As I said before, mass is 0.3 kg. As said you that start drop, whenever the word drops comes, drops means particle starting velocity is always zero. And you know, while falling downwards, gravity always positive 10, and while going upwards gravity always negative 10. These are all properties which done in a topic of kinematics. Okay, this distance is 2 meters while it will travel downwards, and while going upwards 1.4 meter upwards. And common sense, it stops here. So last velocity 100% zero. To make a difference between both particles motion, so student, what I'm going to do, I'm writing here u1, here v1, which is question mark, here v2, here u2, question mark. Okay, now my first target is what? Using this data, I will find v1. V1 means just before hitting the ground, what is the velocity? So let's start to, I'm write a word drop. While drop, okay, so formula 2as is equals to v square minus u square. 2 times 2, acceleration value is 10, you know it very well. S value is 2 meters, is a very clear. Final velocity is my target. I'm writing v1 square, u1 is 0. So when I take a root of this power 2 shifts there, become a root, and is a 40 root. And 40 root, if I type in calculator, so it is turned to be 4 times of 40. So 2 comes outside, 10 inside. So this is a my as just before hitting the ground. Okay. Same way I will go that it is going upward now. Now it's rebound. When you talk about rebound, so naturally data is very clear. So I use again same formula, 2as equal to v square minus u square. Okay, for your knowledge, gravity going upwards, all of you know, is negative 10. Make sure when it's coming downwards, because Earth attracts the particle, it start accelerating, speeding up. That is why it's positive 10 always. But when it's going upwards, Earth attracts the particle, and its speed is slow down, and stop. That is why always negative. That is why negatives represent always deceleration. And I believe you got my point. And here 1.4. And final velocity is 0 for sure, because ultimately it will stop on the peak. And u is my target. And I think up till here all students understood. Now this negative sign in this negative sign. Okay, if I check it here, it is coming, I think, 28. No. Wait a minute. I tell you one thing. I will discuss because some students asking me, sir, I will take positive or negative. No, let me tell you one thing. Observer's eye can be down or can be up. Okay, and I tell you one thing. Hold on. I just show one thing. I will keep observer I is here. Although I can keep it anywhere, no problem at all. But look at here. So observer's I will affect only velocity directions only. Okay. It has no concern with the distances. Make sure. Okay. So let's proceed further. And negative, negative cancel 2 times to 10 into 1.4. I'm getting 28 left side and u square. And negative will cancel from both ends. And u2 I get ultimately root of 28, which is 7 fours are 28, 2 root 7. So now, student, I'm discussing with you that the change in momentum. Now I'm writing the word change in momentum. Basic formula, all of you know mv minus mu. Okay, but hold on, mass. Okay, I can take mass common. Even this will also same formula. Mass is very clear. I mentioned on top 0.3. So I'm writing here 0.3. And now very interesting part, because my observer's eye is up and this particle is going away from observer. So this velocity just before hitting is positive. I will take this value as a positive. So I'm taking here 2 root of 10 as a positive, this count as a V1, and this U2 as a final velocity as a U2. Hold on. I repeat again. Just before hitting, this is called just before hitting, this is after hitting. Okay. And we change the momentum. We can change. Some students can ask me, so can I write MU before, MV later? No effect will come. Same answer. Okay. Now listen to me carefully, because this particle is now going back to observer. So U2 is naturally negative. And I will put this value with the negative sign only here. So look at here, negative 2 root of 7. So one more thing I just tell you, and if you type in calculator, let me type again. Wait a minute, please. 2 root of 10 plus 2 root of 7. And my answer times 2.3. And my final answer is coming with me is, hold on, let me recheck. 1 minute, please. 2 root of 10, hold on, root 40 is short story, and minus root 28, same thing. And that answer times to what? 0.3. Yes, so ultimate answer is coming with me is 0.3099 of it. If I round it, I will get what? 0.31 is my answer, Newton second. And hold on, if you change the places of these two, what effect will come? Only effect will come what? You'll get answer negative, and you will eliminate the negative, because we will never take the I think sign. I think the point is clear, and let's go for next question. uh, Yes, student, there's one correction, please. While typing in calculator, the answer is not that the previous one, the 0.31 wrong. So please make correction. The answer is 3.48. If I check again, now let's talk about back on a textbook. And this question is Alhamdulillah Rabbil Alameen done. And now I'm shifting on collision now. Our main target is collision, because in our exam papers, mostly collision comes, mostly collision. Okay, so but this kind of which I have done, this kind of question are favorite for exam. Even this kind of question are favorite for in which equation of motions, kinematics plus Newton's linear momentum. I mean, linear momentum. So this question is ideal for exam papers, for British Council exam papers. Let's talk about collision. And this is a basic formula, and you know it very well. Oftenly, we have used in the physics also and mathematics as well. So what is that? This is just before collision, and this is just after collision. And what is the law of conservation of momentum is very clear. Before hitting, the momentum of the whole system, and after hitting, momentum of the whole system always conserve. It means remain same. So this is the target hour. I'm going to start now. I repeat, what is ma? Actually, there are two particles. I just show you one thing. This particle a, this particle b, just before hitting. And after hitting, they are different condition. I don't know exactly, but a b. So this is called mass of a. Ma is mass of a. mb mass of b. UA is called starting velocity before collision velocity of A, is start velocity of the B, and this is V is after hitting, after collision. the velocity of A and after hitting the velocity of B. So this formula I'm going to use and get ready for this kind of questions. Okay, here again, the most important thing is arrows. Arrows are very important, and you know very well, if observer's eye is here, this is positive velocity, positive, but this is negative, and this is again positive. Make sure when observe any particle going back to observer, velocity negative. So make sure this is a key point. Okay, that is why you can observe, even he wrote -3, and I believe is nothing hard. So keep in mind, the way I will choose, always same way I will choose. I will write the masses in the all this is not a fixed criteria, but I will write the mass in the circles. Okay, and speeds I will write up or down, even no issue. Let's start one question. I'm going to do one question with you. Bismillah Rahman Rahim. Okay, I'm going to discuss. Wait a minute. First, we'll discuss some. I think this question is good to do. So this question, I'm going to do this one now. All of you get ready. And ultimate, what the question is? You can see the mass of A particles 2 kilograms, speed is 7. Mass of B is a 4 kilograms, speed is 3. Mass of the A is a 2 kilogram, speed unknown. Mass of the B is a 4 kilogram. And sorry, gram. Sorry, he clever given gram here. Okay, and oh, I think, wait a minute. Yes, this is, hold on. Why he given different? Okay, maybe my mistake he given here. This mistake actually. 4 kilogram, 4 kilogram, because masses cannot change the question. Okay, so I think idea is very clear. Let me label it. So this I'm labeling U1, this I'm labeling U2, this I'm labeling V1, this I'm labeling V2. Okay, observer, I can keep here or keep it there, no issue at all. But I will keep the observer's eye here. And now I believe, inshallah, you will understand. But make sure this is a negative. Why? Because it's going back to observer. This is a positive. This is a negative because it's going back to observer. This is a positive. Now I'm starting this question and finish the question, inshallah, in no time. So all of you attentive, formula M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. So whole chapter will use this formula. Let's start. M1 is very clear, 2 times 2, 7. So I'm writing 2, mass is 2, speed is 7. Mass of second particle is 4 kilogram, but speed is -3. I'm writing here -3. Mass 1 is again 2 kilograms, so 2 times 2, and velocity is going backwards. I'm writing -v. Mass of second particle is 4 kilogram and velocity is 2. So I think understanding very clear. But as a teacher, I suggest you, the way he made this diagram, you will make every question. If you will become lazy, you will get a wrong, chances of mistake increases. So 2 sevens are 14, 12, -2v, 4 twos are 8. Here I got a 2 and -2v plus 8. 2v comes this end, 2 goes there, becomes 6. Alhamdulillah Rabbil Alameen. Nothing hard at all. So Mabruk is nothing hard. So give me one favor. In the same way, I'm not erasing my solution. Take your time and solve this question only, but you should take only and only 2 minutes only. Okay, data is written already. Don't waste time. So just write formula and solve it. And now time is 2:46. I'm giving you 3 minutes or 2 minutes maximum. 2:48 or 49, no problem. I will start this explanation. So take your time. I'm going to stop recording. Yes, student, I'm starting now. Bismillah Rahman Rahim. Think you have done it. And make sure this is not gram, the same mistake done before, same mistake write the book writer. I think typing error here only. Come back. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. So I'm writing the values, sorry, variable writing here, okay? So this I'm writing here, U1 equal to 3, okay? And this is U2, and before collision and after collision is a V1, and after collision V2. So this is before collision. I'm writing here before collision. This is a after collision. So let's start. So M1 V1, mass is a 2, V is 3. Again, before you start, make this I is just for you. I am making an exam. You don't make it this I, no issue at all. Okay, examiner has a no concern with this I, only concern with the signs. So this is okay, let me write it before. This is a because away, 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 but this is a backwards. So this is a negative one I will take only. Reason because it's going backwards. So let's start. So M1 is 2, U is 3. 2 into 3. 2 times 2, 3. M2, U2, 3 into V. I'm writing 3 times 2V. Okay, this is what 2 times 2 minus 1. I'm writing 2 times 2 minus 1. What about this 3 times 2? 4. So 3 times 2, 4. And now rest is easy. So 6 plus 3V and negative 2 plus 12. So 3V here, this is a 10, and 6 will come left hand, right hand side. I get negative 6, and 3V equals to 4. And this is a 10, yes, 6 minus. And answer is coming 4 over 3 meter per second. I'm not writing in decimals. I hope so. The point is very, very clear. And now I give one concept to try, but make sure this question you will try number 2 now, but you will make this kind of diagram, please. Okay, and you will and write the data same way the way he made. Okay, write the mass in the circles, and speeds on the top, and and arrows must be there. So try question number 2. I'm giving 5 minutes for question number 2. So I will start after 5 minutes. So take your time, please. I'm going to stop recording. Yes, student, I think you've taken a reasonable time. And let's start question number 2. I'm going to do here. First of all, I will make a diagram before collision and after collision. Okay, so let's start. This is a particle 1. Okay, I will make a copy paste this kind of copy paste. Okay, and again copy and paste, copy and paste. Okay, so this is just before collision, and this is the other one is after collision. After collision. Okay, so mass is given by him is 250 grams divided by 1,000. So I'm writing here 0.25 kilograms. Okay, the other one is a B is a given here two for so divided by 1,000, so 0.45 kilograms. So same masses I'm writing even there. So this is a very important writing is very important here. He says the traveling towards each other. It means 100% this is traveling towards each other. This point is very clear. And I will keep observer's eye at this point. This point. Okay. And U1, okay, I will tell you, and U2 is 100% negative. He's saying that smooth surface and speed of each are 4 and 2. So this is a 4, speed is given by him 4, but here is 2. But while using, I will put negative 2. Even, okay, I think I'm writing here 2, but while using, I will use negative sign. After collision, after they collide, B will reverse its direction. Reverse direction means, let me write, this is A, this is B, this is A, this is B. So B will reverse direction means this direction will go this way. Okay, make sure. And he's saying B direction is reversed. It is now speed is 1. So this is V2 is equals to 1. All right, is it clear? And find the speed of A particle and its direction also. I'm not sure which direction. If I'm not sure, students, I will take this one, unknown V. Okay, or I can take here X, even no problem at all. So speed is of this is unknown, and you will come to know inshallah when I will solve the answer. If it go this way, I will get a positive answer. If I get negative sign, it's 100% it is going back. So let's try to solve it. M1 U1 plus M2 U2 M1 V1 plus M2 V2. So mass is 0.25 into 4. So 0.25 times to 4. But be careful, 0.45, and speed is not 2. Velocity is negative 2. 0.45 into negative 2 because it's going back to observer. Okay, equals to, again, 0.25 into x. So 0.25 times to x. Mass 0.45 into 1. So 0.45 into 1 is same value. So when I type the left hand side, the whole value in my calculator, and I'm getting here negative 0.35. Let me recheck 0.25 into 4 and negative 0.45 into 2. Wait a minute, let me recheck. Maybe I have done some mistake. Hold on. 0.25 into 4 and plus 0.45 into 2, but negative 2. Yeah, it is coming some different value. Hold on, let me recheck. Let me recheck. It is any typing mistake. 4 times 2.25 and negative 0.45 times 2. And I'm getting here 0.1. Let me recheck. Is the right values are correct or wrong? Wait a minute. First is a 4, second is a 2, 4 and 2, and negative 2, correct. 0.25 and 0.45. 0.25, all correct, all correct. Okay, this is done. And now, student, let me talk the other way. 0.25x and 0.45. And this will come this side. And when I subtract 0.1 minus 0.45, I'm getting here negative 0.35 equal to 0.25x. If I divide by this, so student, what I get answer? I'm getting answer here is I'm writing here x is equals to negative 1.4. So it means speed turned to be 1.4 meter per second, but it is a reverse direction. I mean, towards observer first, or you can say first it is going away, now it's coming back. So I can say its direction is reverse. Direction is reverse. I hope so. Got the idea very clear. And the whole story is very clear because this negative telling us that it's going back to observer, as I said before. So Alhamdulillah Rabbil Alameen, I believe the point is very clear and time of lecture is over. So I'm going to assign few questions of homework. Question number 2, if you done correct, okay. Otherwise, redo. Number 3, number 4, number 5, and I think so number 6. So these questions are your homework. Inshallah, second lecture is tomorrow, and tomorrow we'll start our past papers, inshallah, and that's it.